He could be here on webcam.
He could.
Do I have to stand there, or can you just record my voice?
You record your voice.
Patty, just walk around. Why don't we just have a huge camera?
I wondered what she was doing. Okay, so anyways, welcome back everybody. If you do have questions about the upcoming examination, I would be glad to help out as best as I can. I'm hoping that you will have some questions prepared in advance. Some of you may even want to respond to your colleague's question, and then I will try to provide a response whenever I can do so as well. So let's begin with the first question to Tyler. How is that apple?
Really good.
Really good. Oh, not just
Best one of the year.
Is it really? I feel quite excited. Okay, very, very good. And let's go to the second question. Who would like to ask the second question? Tyler?
What is the first question on the test?
Let's go immediately to the third question. Mr. Downey, did you have a question?
Yeah, like what all are we gonna have to, what all are we supposed to know?
What all are you supposed to know?
Or are we supposed to be able to recall off the top of our head?
Okay, you need to be familiar with and comfortable with all of the material that is in the second module. You also need to be familiar and comfortable with everything that is in laboratory assignments 4, 5, and 6. Now, what is the second module exclusively about? Some of you may be familiar with this. I've said it a few times in the past. We're talking about the material in Chapter 3 that is related to Section 3.1, 3.2, and 3.3. That is arrays, linked lists that are singly linked, and linked lists that are doubly linked. So, Mr. Dowdy, the first thing is the material in 3.1, 3.2, and 3.3 using arrays, singly linked lists, and doubly linked lists. Of course, you should still be familiar with the analysis tools material. That is, what is the big O notation, what does it mean, and how do we use it in order to study the performance of our algorithms. So for example, we talked about the fact that the push method for a stack with an array, if implemented correctly, would be big O1. You should be able to explain what that means and how you arrived at the big O1 implementation. And then finally, the really key area of study is the material that was in Chapter 5, stacks, queues, and double-ended queues. And that, I think, gives at least a preliminary response to your question. Any other clarifying questions about that issue? Also, please be aware of the fact that the examination will be structured in a similar way to what you have seen in the past for the previous test. That means that there will be a total of 5 questions. Each question will have multiple parts. The parts of the question will be individually labeled for their point totals. And you should take the examination by operating as a point maximizer. Remember, you can do question 4B first if you think that's a good idea. If Alex wants to answer question 5 first, he can do that. Again, I would encourage you to look over the whole test, make an intelligent decision about the order in which you will answer the questions, follow through with that choice. The other thing that you need to be aware of is that I can assign you no partial credit if you don't write down something. So I would encourage you to at least put a preliminary response if you're not sure how to give a detailed answer. And then finally, I always tell my students that you should try to manage your time carefully. Generally speaking, you should time yourself and follow through with about 10 minutes per question. 10 to 12 minutes per question. I do want you to finish the examination on time. I reserve the right to assign a penalty if you turn the test in late. This is not because I want to proceed in a draconian or mean-spirited fashion, but it's due to the fact that I have to be fair to all students, even those who have to go to an examination or another class after this one. Yes?
Do you have an outline for your penalty system?
Say it again?
Do you have an outline for your penalty system?
I do not.
Like, how many points, like, get taken off if I turned in like 10 minutes late?
I do not. The answer is, all that I tell my students is that I reserve the right to assign a penalty if you turn the material in late. And the key thing is to say, I want you to turn in the examination on time.
All right.
Okay?
All right.
And I'm doing that because I want to be as fair as I possibly can to you and all of your colleagues. And I know some people have examinations coming up afterwards, or they may have a class to attend afterwards, and so that's why I have to set that time limit. I know that there are professors at Allegheny that do things like, if I give you this hint, I'm going to take away 2 points, is that okay with you? And you have like a little bartering session in the professor's office. And then other professors have like this scale by how many points you lose if it's over this many minutes or this many minutes, and you can negotiate based upon how much longer you want to work. But I always thought that that kind of took away from the point of the examination, which was you expressing everything you know and understand to me, and me giving you a fair evaluation when I grade the test. Yes?
What if we come back, say, like at 4, and like, you know, you give out the thing that, and that everyone's available at 4, and they come back and you all do an honors order and get, say, 31 minutes to work on it? Is that possible?
The problem that we run into then is a scheduling challenge, because there's no guarantee that everybody can make it at a given time.
What if you send out an email and check it out?
I'm sure
I may be willing to entertain such a thing, but I really do think that it's an examination that you can finish in the time period allotted. I have taught this class many times in the past. All of your 4 colleagues, those who came before you, could finish the test in that's a new term, I just made it up, and it's great on video. They have been able to finish the test in time, and I think you will be able to as well.
Maybe you're a special class. Just
Well,
like
you are.
Jaden was saying.
You are a very special class, and I would agree with that. And I'm confident that you'll be able to do well and finish. It really comes down to making sure that as you're studying, these topics are like your old friends. And you say, oh, there's my old friend, the queue implemented with a linked list. And if you know everything about your old friend, the queue implemented with a linked list, it will be very easy for you to respond with some details about how that implementation works or what its performance looks like. Okay, so generally speaking, my observation is I would prefer not to extend to different periods of time. Other questions? Yes?
There are a lot of questions in terms of creating a stack from scratch, like their array-based implementation. Yeah. Are we supposed to be able to do it all by ourselves?
Okay. Can you tell everyone the page number?
Page 206.
Okay. I talked about exactly this issue with a couple other students, so I'm glad that you brought this up. He's referring to the material on page 206. Okay? And it's a simple array-based stack implementation. Now, actually, it turns out we did go over this pseudocode, but I used a textual description and I used a diagram. But if you think about it, we went through and we said which methods can throw which exceptions. Remember we did that? And then we said we need a top of the stack pointer t. What should be the data type of that variable? Oh, it should be an int. What if we're going to use an array? How do we index the array? We do s sub t for the top. And then we talked a little bit about how we could implement these methods by moving the stack of the pointer up when we push something on and moving it down when we pop something off. So you should at minimum be able to understand the concepts. If you push, you have to put the data into the array and then change the top of the stack pointer. If you push, but the stack is already full, then you have to throw an exception to say that the stack is full. So Aman, I think the quick response to your question is, first of all, you should know that all of these methods are big O1. And in fact, that's reinforced in table 5.1 on the next page. The other thing that you should be